Alright nerds, so now we're going to move from the greenhouse effect, which is the very basic underlying fact, to the theory of global climate change. Now, I'm just going to write one thing here. If we call something a theory, we don't mean that it is an idea that we have. We mean that it is a fact that explains why it's true and makes predictions of the future. So what will happen. So when we call climate change or anything else a theory, that's actually giving it a really high bit of praise there. Like that's saying that it is essentially the highest level of knowledge we have in science. Okay, so theory is not just an idea you have, like I have a theory that some of you aren't going to do your homework. It is based in evidence. It is shown to be true every single time it's tested, and it makes predictions for future occurrences. So that's what a theory is. So we're going to move from the greenhouse effect fact, which is just a simple state of this does this, to the global climate change theory, which explains what happens because of greenhouse gases. So what's the point? You want to be able to define climate change. Cool. You want to be able to differentiate between weather and climate. And that's job number one. That's the first thing we'll do. You also want to be able to explain the causes and potential impacts. Now, causes, yes. Potential impacts, we'll see how we go, depending on how time is. So what you need to remember, basically you need to remember that the greenhouse effect is a well-established scientific theory. Well, it is actually a theory, but we're using it as a basic fact to build the next theory onto, that describes basically how the gases in the atmosphere affect the temperature on Earth. Now, the enhanced greenhouse effect includes the contribution of humans to the greenhouse effect because we're so industrious and we help out so much. So, weather and climate. Let's have a quick look here. So, what is weather? It's basically the atmospheric conditions at a specific place and a specific point in time. It's real-time measurements. It's what's the weather like outside now? Climate is the average set of conditions for that place at a given time. Okay, it aggregates weather statistics for over long periods of time. We call these climate normals or norms, and at the moment the climate norms are shifting hotter. So let's have a look. We'll ignore this, we'll come back to this in a sec. So this straight line here, this is the climate, the temperature for the Earth increasing, and we can see that the trend is that it's going up. That's that straight line. But these are the actual weather points. And you can see that some years it's really cold, or some days, depending on it. Some days it's higher. This could be for rain. It could be the rain is increasing over time. Some days the rain is less, some days the rain is more. Depends on the individual day. But climate is actually the long trend. Okay, here's our sink that we looked at before in one of the previous lessons. The straight line along there, that's your climate. That's what the level of water is average, but then you've got all these like fluctuations along it. Those fluctuations are the weather. So how does climate change work? This is just the greenhouse gas again. We're going to just very, very briefly, basically the light, visible light comes in, some of it's reflected away, some of it isn't. The infrared radiation is emitted from the Earth, but some of it, in a growing larger and larger amount, gets emitted back down by the gases in the atmosphere. Here's how it works. So you can see infrared radiation gets emitted up, hits the gas, and some of it will be re-emitted back down, some will go up, some go sideways, back down. It goes through all directions, okay? It's not a straight back down, it's across directions. All right, so very quickly, we've looked at climate change. We'll get more into it in a second. So what is climate change? We'll go back to that last graph in a second. Basically, climate change is a change in these average aspects of the climate that can persist for decades or longer. Now, the climate actually changes in a cyclical fashion, so in cycles. Naturally, it just does this. And we see this here. So here's the amount of carbon dioxide. This is over the last 800,000 years. The carbon dioxide levels go up and down. Okay, that's pretty sweet. And here's the Antarctic temperature. Now, we use the Antarctic temperature because we can measure it in the ice bubbles. So we can use the ice cores essentially to measure it. We'll get to how we do this stuff in a future video. But we can use the ice cores to measure the temperature. And you can see that they see how well they track along. Now, don't get me wrong, these have to be scaled slightly differently to each other to make them fit, but they do fit. So we can see these ones going along like this, and you can see they match pretty nicely. Anthropogenic climate change. Okay, that word there. Know that. That means these are the changes to the climate as a result of human activity. Anthropogenic climate change. Say it with me, anthropogenic. Okay, these are changes to the climate as a result of human activity. Now, there is a direct correlation between the rise in average global temperatures beyond these background cycles and the rise in greenhouse gases produced by human activity. Not just carbon dioxide, that's the main one. That's the one that's we really worry about, but there's other ones there as well, water vapor. But water vapor is short term, carbon dioxide stays for a long time, and so forth. Okay, so, we'll just get rid of all the crap off the slide. This is what it looks like. So you can see this is the last 800,000 years, the same graph. And there's the CO2 concentrations. It's done this, done this, done this. And then you see right now, here's the last 1,000 years, it's going up. And there's pretty much the last couple hundred years. And it shoots straight up. So I wonder what sort of effect that could have. Well, luckily, we have the last 1,000 years present for us in a graph. And we can see that what actually happens is they track together very, very nicely. The blue line is carbon dioxide. The red line is the temperature. So you can see that they actually track together quite nicely. And then we see what happens in the last 100 years or so. In the last 100 years, we've just gone to town with cars. We've gone to town with all sorts of stuff. And it just, industrially, we've kicked it up a notch. And we can just see that they both go straight up. All right, here we are again. This graph here is actually quite interesting. These are our modeling, okay? So if we were modeling what we would see with just the natural forces, so if you took the anthropogenic climate change out of the situation, this is what you get. It goes up, it goes down, it goes up and down. When they model in from all of our information that we have, and they take out what they've actually seen, but they just model in all the effects that we should have with everything we pump into it, you get this nice pink line. But then they put in the actual temperatures of what we've seen over the last 100 years, and you can see that it continues to rise, and it goes up quite neatly. It fits that, so their modeling is actually pretty good. So the effects that this can have, it's a really big deal, by the way. These are in the year 2000, so the number of deaths per million people that we can attribute to climate change. So in Australia, it's probably pretty close to zero. It's 0 to 2 per million people. Climate change can, of course, result in increased heat waves, and that can result in deaths. Cool. So these parts, they're all right. They're not such a big deal. But down here, you start to get towards 2 to 4. 4 to 70, that's a big jump. And 70 to 100. And what you notice is that it's usually the quite poorer parts of the world and the drier parts of the world that have these increased risk of mortality. So these are the deaths per million people. So 70 people out of a million people died due to climate change, at least in these red countries. All right, so these are the actual effects of anthropogenic climate change. So higher rates of transpiration from the trees. So this means they lose water into the atmosphere. By the way, that actually increases the global temperatures further. That's going to be a scary trend that you see. Glaciers melt, and the snow melt. It happens. It's ice and snow for less. Okay, and this means the water rushes into the seas. The sea level rises. Okay, we get more frequent floods. Okay, so your water goes down, floods. All right. You also get, but the more water in here, the more water goes up into the atmosphere, and you can see that it feeds further in. You get increased evaporation from reservoirs and water bodies, which means you've got more water. So you've got less water in your dams, less water in your reservoirs, but more water in the atmosphere, which actually, again, heats up the atmosphere further. You get increased variability of precipitations and more extreme events. So the weather becomes less predictable. You get more frequent and longer periods of the soil not having enough water in it, so having to use more just to grow food. Again, water is decreasing. And that's because the water's all up here or in the ocean. You get more pressure on the groundwater, so we have to pull more water out of the ground. And anyone who understands about using bore water, that increases the salinity of the soil. So you get increased demand for irrigation water. And longer periods of low flow affecting water users and industry. So the rivers just don't have as much water in them. See, a lot of these, particularly the polar ice caps, when they start to melt, well then, again, the water rises. But they're really good at reflecting a large amount of the heat back into the atmosphere, or back into space. But because their bright, shiny whiteness disappears, you got less reflecting it. So you see, it's not all depressing. We can do stuff about it, but this is the potential effects if it just continues unchecked as we go. So here we're going to have a quick look, very, very quick look, at the impacts of it. So if we increase our temperature by about 0.8 degrees, we're going to get more heat waves. The oceans will warm, the Arctic ice caps will melt, sea levels will rise. You'll get extreme weather events, and species will become extinct. Okay, if we go up 1 degree, more extinctions, coral reefs disappearing, island nations will go underwater. Okay, so that means you start to get your refugees. If we go up 2 degrees, Greenland disappears. Well, it doesn't disappear; it melts. Polar bears will go extinct, and the water supply will start to be affected. Just not enough rain. And when you get the rain, it's not going to be in the right places. If we go up 3 degrees, it is predicted that the Amazon ecosystem will collapse entirely. And that one's in danger as it is. There will be then food shortages, and we'll start to see mass environmental refugees. If we go up by 4 degrees, you end up with millions of refugees. That's actually predicted to be billions of refugees now. 1/3 of Bangladesh will be underwater. The permafrost melts, as will and all the gases which are trapped under there released. Now, as those gases released, you might be surprised to know that most of them are greenhouse gases, and it gets worse. If we go up 5 or 6 degrees, we start to get mass extinctions, and that affects everyone, including us. So, as I said, there are ways around this stuff, and we'll get to that later on. Stay cheery. See you in class.